This section is Application Lifecycle Management. Know various ways to configure applications. So first of all, quite frankly, I'm quite happy to be done just using config maps and start introducing additional Kubernetes persistent objects. Also, just a side note, I'm going to run with the assumption that the reader or the watcher is somewhat familiar with containers, maybe in the context of Docker, things like images, containers, and repositories. If you're not, I have a link in the script to it's Docker's quick start on containers, and it kind of gets you the main concepts of around, just containers and how you use them, and the relationship between images and containers in particular. So I will let you do that on your own, right? So with that in mind, the first Kubernetes concept we're going to introduce is called a pod. It's essentially the simplest unit of application, an application you can run in Kubernetes. And essentially, think of a pod as a list or a grouping of containers that are tightly coupled. So most often, you really just deploy a single container inside of a pod. So, but there are concepts of multi-container pods. And in this case, we're just going to do the simplest case, which is a single container pod all throughout this video, at least. What I did here was I already scaffolded a Helm application or a Kubernetes application, right, by using a Helm create hello pod. And then I kind of cleaned it out. So let me see what we have here. Hello pod. I created it. I wiped out the templates, wiped out the values, and then I went into templates and I created the new entry here. So we're going to look at this. So we're going to look at kind of the bare minimum of creating a pod, right? So just like all the other APIs that are templates that we've been using, right? You have first specify the API version, and pod is part of the core API, so that's why there's no group here. It's just V1, right? It's a pod with a capital P, and if you didn't know that, you could have used that kube control get resource API resources. I think actually is a sidebar. Make sure if I do kube control API resources, I believe. And if I do that, right, you'll see that pod is part of the core group. Its short name is PO, it's pods, and it's capital pod. And it is a namespaced object, right? Okay, so that's just a side note. Okay, it's pod. Just like any other Kubernetes object, you can do metadata, right? And I'm going to use the pattern that I carried from the last example with Helm, I believe, where I have using the name, instance, and version meta labels, right? Metadata labels. And then the name, I'm going to base it on the release name, right? Now here's where it's new. There's a spec, right? So this is an object that will have a spec and a status. And it's pretty obvious what's going on here, right? I just told you that the pod was a listing or an array of grouping or a set of containers. And this one so the only entry here I have is containers, and I have a name of a container. The name itself is arbitrary. It's not tied to anything else other than just a name. Image is got to refer to something important. So image in this case is referring to if I was to go to Docker Ubuntu, there is Docker Hub, which is a official repository or a bunch of repositories, and here is Ubuntu, right? And there's different versions of Ubuntu here. They have the tags, right? So I used 1804. So this is coming from a public repository. As a side note, you can use Amazon. If you're using Amazon, Amazon has their Elastic Container Repository, ECR, where you can deploy. It's a private repository where you can put in your own containers or your own images there. but we're not going to do that here. We're just going to use a public Ubuntu image. Okay, back to what we're doing. So the image has, in this case, because there's no full URL, this is referring to something that's coming from the Docker Hub. And then the command, in this case, with Ubuntu, I want to ensure that it stays up and running, right? I want a command that sort of infinitely just runs and doesn't exit in this particular example. So you can see that I overrode the command with tail minus fdev null, which is basically kind of a cheat way of causing this Ubuntu container to never exit. So basically that command tail will just run indefinitely. And then we can kind of use it, we can explore this container as it's running. Okay, so that's the structure of the minimal definition of a pod. And so let's go ahead and deploy that pod. Make sure I'm not forgetting something. Right, so we're just going to install that pod. So let me go back here, go back to the right folder, Helm, install, hello, pod. Oh, right, you have to say, this is Helm, so I have to do a release name, then hello pod, which is the chart. So that should deploy a chart that contains a single pod, right? So if I do Helm ls, I can see my chart dev, and then it contains kube control get pod, cube control get pod. Okay, there's my pod. It's running. Okay, so we're going to start poking around this pod a little bit and just learn some concepts around how to troubleshoot pods, or just at least start to begin to understand what pods are and how you can inspect them. A couple things about pods before we start going into some deep stuff. One is you should think of pods as being ephemeral, right? So what this means is if, say, a pod, say the node itself failed for some reason that the pod was running on, right? Because pods run on nodes, right? And for whatever reason it dies, the node dies, all the pods on it will die. And as constructed, pods don't get rematerialized. They're gone. So they have there's no thing ensuring that pods stay up and running. They're up and running. As long as they're running, they're fine. But if the node dies, they die too. So and I guess the key is they're saying they're not rescheduled on a new node. Another thing is you should be thinking about pods as being sort of immutable, right? So once you create a pod, you can't do things like add new containers to them. They pretty much are what they are. There are other mechanisms to basically swap out pods for newer pods, and we'll get to that later. But the key point here is you should be thinking them as ephemeral and essentially immutable. You can't change pods after the fact. All you can do is replace pods. And as a matter of fact, just to illustrate that, let's see if we do a quick test here. If I was to go into my pod definition, templates, and if I was to go in here just to try to illustrate this, I'm going to add another container here called Ubuntu 2. Right? In theory, you'd think that all this would do is add a new container to the pod, right? Instead, if you try to deploy this, Helm upgrade dev hello pod, what did I do? Misspelled upgrade apparently. It's going to try to upgrade it by adding it, and you notice that the upgrade failed because basically it tells you pod updates may not add or remove containers. Right, so it tells you exactly what happened there. So get status. I want to check. Let me get rid of this. Get checkout. I want to get rid of that change. Okay, clear. Okay, so again, pods are ephemeral and essentially immutable. And we'll learn some of the concepts of how to swap out pods. Another thing is, let's go at pods as they start up. There's events. So if I do a command called kube control describe pod, and then the pod name here is dev dash, no, it's hello dash dev. At the bottom, right, you can see that there's some events. So I'm going to kind of quickly glance over the events, just put them in context. Now, one thing I did notice, by the way, is that these events are the most recent events, and it looks like, as configured, these events don't live very long. So if I wait 15 minutes, these events eventually will roll off, and I can't see these events anymore. In fact, there should be a command here. I'm going to try this here. Get events. Right, so there's the same events, but if I wait 15 minutes, those events will no longer be here. Okay, let me go back to get it in the context of the pod, though. Okay, so the first thing you'll see, this is ordered from top to bottom, right? It tells you how old the event is, and so the newest ones are at the bottom. So you can see the first thing, when this pod was attempted to be run, right, it tried to schedule it to the node. So the scheduler process, right, had to figure out which node to put it on. That's what that first thing was, right? And then about 1 second later, it basically determined that the image for Ubuntu was already present on the machine. So it can, if it's not already in the machine, it will then pull it down, and then it can run off the cache. So that's what that line is saying. That's why it didn't take very long to go to the next step, right? Because it had the image already, it can create the container very fast, and then once it created it, it started the container, and then the container starts running, right? So there's some events there you can use in your troubleshooting to see maybe the image was invalid. There's all sorts of reasons why this may not start, and you can use the events as your first line of defense in troubleshooting this. Okay, and just so you know, in the next video, we're going to deliberately break things to try to explore how we can use these different pod objects or things related to pods to troubleshoot. Okay, the next concept is a pod phase. So if let's just go through here. If I see, I'm going to do a couple commands. Kube control get pod, and you'll notice there's a status. Now it turns out this status is the same thing as the phase. It's a little confusing that they use the word. But as you go in the documentation and elsewhere, we'll see that this status is really the same thing as the phase, and it's running. To see this in another context, if I do kube control get describe pod hello dev, you will see it also there's more information here, obviously, and in the status, you will see, if I can find it, there it is here. It says status running. Now, it turns out, again, it's a little confusing because they use the word status here, but if you do kube control, the most detailed view of this is get pod, what is this again? I just spaced out. Problem is, this is hello dev. If you do the -o YAML, this gives you the most detailed view of the pod, right? And you'll notice, if I can find it, under status, here they refer to that same thing that we were calling status before is now phase. And the documentation physically calls it the phase. So I'm going to refer to it as the phase going forward, even though status is used in multiple places. So here it's running. So the quick, oops. Not mean to click on that. Let me go back to this. Right. So what is the value of this phase, right? There are a couple different values, and I'll just quickly go through them. And again, we're going to recreate some errors later in the next video to see these different states. So when your pod first starts up, it's in a pending state, where it's trying to download the images, it's getting ready to go. That's the pending. And then it starts with running. And then basically once all the containers have been created and at least one container is still operational, right, running, the process is running. In this case, that's what's happening to us. If the pod is one that the So these processes that are running can actually exit, right? And if all the processes exit in success, and we'll again see an example of this, and it's not set to restart, and we'll talk about that too, then it can be marked as succeeded. If the containers, let's see, if all the containers have terminated, and at least one is terminated in failure, right? And there's no process restarting containers, then the pod will be failed, right? So, and then unknown is pretty much what it is. Now, one of the things that they're careful in the documentation is be very careful about reading these definitions. It's easy to misinterpret what these mean. Like running might, in your mind, mean everything's okay, and it's not necessarily okay. All it means, again, is that at least one container is still running, right? Or, actually look carefully, at least one container is running or in the process of starting or restarting even. Okay, and I think that's what I was getting at. Even though your pod may be running, your containers may be in a different variety of states. Okay, so there's there's another piece called pod conditions, and we'll look at the output real quick. And this tells you a lot more detail about what's going on with the pod. As a matter of fact, if you just do, here, let's do it first, and then we'll look at the definitions. So I guess first you look at the status slash, I'm already using the wrong word now, status and or phase, right? And then pod conditions provide you more information about what's really going on with it. So if we do kube control, describe pod, hello, and I'm losing my mind here. Okay, so you see these conditions right here? And so they're basically true or false values. In this case, everything's true, right? Again, we'll break this on purpose later in another example to start to illustrate these different patterns, right? You can also see there's that. If I run the same thing with kube control, get pod, what is this thing called? Hello dev output YAML, right? You will also see the conditions, but now it's got more detail around the conditions. So not just the status, but it also has the last time it transitioned of this condition, last time it transitioned, right? And depending on the status, you may get more detail too. The status true is pretty much, you're just going to get true, but you can get more details as you go, if there's problems. Okay. So let's talk about what each of these kind of I'm going to do it sort of sequentially in terms of time, right? So the first one of the conditions is pod scheduled, right? And it essentially says the pod has been scheduled to a node. It's either true or false. So that's usually the first thing that happens. The pod is now running on, or at least scheduled to run on a node. There's the next step is there's some specialized containers, which we won't cover in this video, but we will get to, called Init Containers. They're just another container that's in your mix, but they actually run first, and they have special characteristics, so we're going to postpone it. But initialize means the init containers have already started, right? And then once all the containers themselves are ready, right? So this is getting into more detail again about what's happening inside the pod. If all the containers are ready, then the pod is considered, the containers ready flag sets true, right? And then separately, the pod has a concept of it being ready, independent of all of its pods being ready. And this is really when the pod itself is ready. That's where it's ready to be used in a production way, where it gets. And again, we'll talk about services later, but that once a pod is ready is when it's really ready to go to be used for what's its intentional purposes, right? And later on, we'll talk about one thing that might be confusing too is the differentiation between all the containers being ready versus the pod itself being ready. At first glance, you might think, well, if all the containers are ready, why isn't the pod ready? And we'll explore that later too. I think we've already looked at these commands, so that's Again, so just a recap, we've talked about the pod status or the phase. It kind of gives you a very coarse status of where it's at. The pod conditions gives you more details about what's happening at the pod level, right? And then the obviously next thing is, okay, now you need to know about what's happening to the containers, right? So maybe the containers are not ready, and we need to figure out what their statuses are. Now, a pod can be, it's not a pod, a container itself can be one of three states, right? And we'll look at the command here in a minute, but there's waiting, and they kind of start off with waiting, right? So that's the initial state of a container is waiting. And essentially, they're pulling their images, they're doing things to get themselves ready, right? At some point, they get marked as being running, and basically the container is now executing without any issues, right? And then there's terminated, means it stopped. It can either stop in a happy state, meaning it has a good status code, or it can stop in a failed state. In this case, ours is running, right? Now, one thing that's a little tricky is earlier we were talking about containers being ready, and here we're talking about running, okay? So there's a distinction again. And for now, for the purpose of this video, we're going to say that, hey, once a container is running, we're going to say that it's automatically, hang on a second. Oh, okay, there's two levels of complexity here. So the question is, when is a container running, right? And if you think about our definition is, one definition might be, hey, once the container is running is when the entry point is executed and then it's doing whatever it's doing, right? Now it turns out there's for this, our example right now, that's accurate. There's some more detail underneath that, right? So, and then the separate thing was what I was trying to get after earlier is there's a distinction between a container being ready and running, right? And we'll talk about that. Right now, for the purposes of this exact container, they're the same thing because we haven't defined one of these things called a readiness probe, in which case running is equivalent to ready, but there is a concept of ready that's separate from running. Okay, so with all that in mind, let's look at that first, and then there's one more thing to talk about, kind of related to this. So let me output the, right? So let's look at these values, this container business. So if you look carefully at this, there's the conditions again, but then they have the container statuses, right? And you'll notice here, if I look carefully, here's the container, right? This is the Ubuntu image, and ready is true, which is one part of this, but the state is also running. So there's two flags, ready and run, and the state. So it's running, and then somehow it's transitioned also to being ready in this case. And again, we'll explore that distinction between ready and state running. And then, right, and this running, you gotta be careful about your indentation. That running there refers to the pod, whereas this refers to the, this right here refers to the container. Okay. Okay, so the next step is, one thing I didn't mention here. So the question might be, well, what happens when, you have got these containers running, right? What happens if a container just decides to fail, right? It goes from running and it terminates because of some, I don't know, bug in your software and it crashes, right? The default, let me look carefully here. There, under your pod spec up here, we didn't specify it, but it was defaulted to a value, this restart policy. It says always. So always is set means if any container terminates for whatever reason, either successfully or unsuccessfully, I'm going to restart, the pod is going to restart that container. So that's the behavior. In this case, so no matter what happens with the inside of the Ubuntu container, it will always get restarted if for whatever reason it exits, right? There are other settings for this. So the other restart policies are on failure. So if it exits gracefully, it won't start, but if it exits on a failure, it will restart. And then the never example is, regardless whether it fails successfully or unsuccessfully, right? I mean, if it exits successfully or unsuccessfully, it'll never restart. So ours defaulted always, which means it's more like running like a web service, right? It's always going to be there, always try to be there at least. There is some timing things about when it tries to restart that container. You can see it's got an exponential back-off delay, blah, blah, blah. So there's some details of it. It doesn't just always just restart. It will back off for a while, let it cool down, and then try to start it again. Okay. So that's a lot about sort of the life cycle of the pods and the containers and their various states. So we're going to actually interact with this container for a few minutes. And the first thing we're going to do is just run some commands on this container since it's still running, right? So the first thing I'm going to do is, let me just type it and then, so I'm going to run kubectl exec, means to execute a command, right? On the container hello dev. -- means separates out this command and the commands you're going to pass to the container. And ls just gives me a list of folders and files, right? So that's the list of the default directory, which happens to be root. So that's the first command you can run. Or you can run that's an example of a command, right? Another example of a command here, let me copy and paste it. And then we'll do it. I'll talk about it. So it says execute into that container, right? Now, I'm going to make a distinction. Hello dev is actually a reference to a pod, which happens to have only one container, in which case it knows to go into one container. So we'll talk about that in a second, but this is really executing into the container, not the pod. And then IT stands for, I think it's interactive terminal, right? And bash is a command line interpreter. So this will basically log me in to the container, and then I can do my ls command just like it did remotely. So that's that. The other thing that's mentioned here is if you have more than one container, then you can actually add a container, and then you give a name of the container. In this case, it was Ubuntu, I believe. Right? So you can pick which container that you want to run into. In this case, there's only one container, so it doesn't matter. But that's another side note. You can specify which container you're actually running your commands in. Okay. Okay, I think we're on with that. So the next thing to look at is, okay, so we're inside of our container. There's a couple, your container's kind of running in the context of a pod, which is running in the context of your cluster, right? So there are some things that your container gets kind of from the parents here, right? One is it gets a file system, right? So, I can do ls and there's files here. I can create files here, right? I can, it basically operates like a computer. So you get a file system and you get what's called a writable layer. I'm going to add that right now. So you get a layer where you can now write stuff, right? Another thing you get is information about the container, and we'll look at that in a second. And then you get also, information about other things in the cluster. So the first thing I'm going to do is type in the word hostname. And you'll notice that the hostname, that's basically the name of the pod, and that's one bit of information that your container gets is you get the name of the pod that it's running in by running hostname, right? Another thing you get is if you do print environment, which is basically dumping all the environment variables that your pod is running under, you will notice that you see Kubernetes things all here. One is you get your hostname again, right? There's your hostname. But you get other things here. There's all these Kubernetes ports and services. And I think the one I'll focus on here primarily is the Kubernetes service host and Kubernetes service port. These other ones seem like some combination of the same thing, to be honest. But the point is that within the cluster, if I needed to talk to the Kubernetes API from this container, I should be able to run my Kubernetes commands against this IP address on port 443, is what this tells me. But I'm not going to do that right now. We'll look at that later. How to use this Kubernetes service port from a container. But the point is that's an example of cluster information being injected into this environment. Now, another thing you get actually is, and I think I don't have DNS on here, so let me quickly update my container, just so I can do something here, and then let me install something called DNS Utilities, which allows me to do NS lookup, which is a DNS lookup. So let me install that. Should only take a second. And what I'm getting after here is if I do NS lookup on Kubernetes, right? That same IP address, if you looked at the environment variable, this is the same address, this 10.100.0.1. So this is another way for me to discover from the container the service of Kubernetes, which is the API service. Okay, so that's kind of the main things that you're getting from, in the container from the outside. Okay. Now, there's one other thing here, though, I didn't mention, is when right now I have installed NS lookup on here, so I installed stuff into that writable layer. If, for whatever reason, this container itself died and the pod is resets, its restart policy is always, so it's going to recreate a new container. The data that in that writable layer goes away. So if for whatever reason, and we'll explore this later, but if this container was to basically get restarted, right, then the NS lookup command will no longer be there, right? So you should not treat that writable layer as something that you persist, really. It's really only very transitory, and it's not something you want to store data in for sure. We'll explore something called volumes later, which will address some of those persistence issues, right? So keep in mind that layer is really just a temporary, keep light amount of data there, temp files while you're processing something at most. Okay. Right. Okay, so last thing I want to do here is, this is just kind of a side note. Let's go back here. Let me get out of this. Okay, so I'm back on my machine, kube control, get pod. I should see the one pod running, right? And if I get describe pod hello dev, you can see one of the bits of data that's in here is it tells you what node it's running on. So right here, right? Now in this case, normally I have two nodes running in my this Elastic Kubernetes service, but to save money, I'm only running one, so I already know it has to be on the one. But this is one way to figure out which node it's actually running on. And what I'm going to do is I'm going to log into the node itself, and I'm going to look at Docker and see if I can find the containers, right? Because this is, if you think about how this works, is under the hood, Kubernetes is using Docker, right, on the node to run your containers. That's the container engine. So let's validate that. So what I'm going to do is, actually, I already had done this earlier, so let's see if I can find it. Right, so I had logged in previously to my Bastion host, right? Because in this configuration, we have a Bastion host. And then I use the -A, which is like agent mode, which allows me to pass my PEM key through. So if I'm just going to go ahead and do this. I'm going to go to secure shell, A, EC2, EC user at 287.8.2.11. Right, and then right now I think I already did this right before this, and this is if you were to go back, you would notice that this is the IP address, the private IP address of the node, so I can secure shell there, and now I'm on my node, and as such I should be able to I can log in as root. right? And I can do Docker container. If I do Docker container ls, I'll see a bunch of containers. Partly is, if you remember, there was other things running on the node. There was a proxy, there was the metric server now. We had other things running on that were system level things. So what I'm going to do is I'm going to run grep hello. And you can see, let me clear the screen so it's not so busy. You can see that there's two entries here, which may be first very confusing, right? One looks familiar. You can see it's running, essentially, the command is the tail minus dev null. So that's the one I'm expecting, right? And yet there seems to be this other container here that's tied to the word hello. Where's the word hello in here? I don't even see it, but it's got to be here somewhere. Oh, there it is right here. Hello, it's in red. That's why I couldn't see it. So this is part of that pod. And so there's one of the things that under the hood, there is an extra container. Every time you run a pod, there's an extra container called the pods container. And the documentation is not, it's hidden, right? It's not intended you to really look at. It's used internally within Kubernetes. And it's something that Kubernetes interacts with, something to do with allocating IP addresses. I don't actually understand it, but I know it exists. Only place you're going to see it is if you go behind the scenes, like I did, look at the actual containers running on your node. It's the only time you'll actually see it. Okay, so let me get out of that. To clean up, I go back to my machine, and I believe I'm on my machine now. And then if I want to clean up, I just do helm uninstall dev. If I got it right, it should then schedule my pod to be terminated. Again, this is pretty much the only way to get rid of a pod, right? Or the node goes down. Okay, so that's it for this video. A little bit meandering. We'll come back to all these same concepts in the next video in the context of troubleshooting more.